Hi class, this video we will talk about linear search. So what is the linear search? Linear search usually is when we talk about an array or a vector. We are looking for a value from the array. So in order to find that value, suppose we need to write a for loop. For I equal to 0 for the index, I less than the capacity of the array. If we find that value match, so then we will break from the loop. Otherwise, we need to go over the whole for loop, even we not find that value. So if you remember, the past couple weeks, I talked about a little definition about the big O notation. So the big O notation, sometimes simply to see what is the big O, that will be a way to evaluate the efficiency for the algorithm. So whenever you see a for loop, that means the big O is n. Easy to say is, remember if you have a for loop, for I equal to 0, I less than n, so you need to do average n over 2 times. Or sometimes the worst case is you need to do n times. So that's the n notation. So when we do the linear search, the big O will be n. So the next clip, I will talk about the binary search. I will explain why the binary search, the big O will be log n. But let's focus on linear search for this exam, for this clip. Okay, so now I want you to think about how to write a function for that. Like earlier I said, we have an array. I know the array size, and I'm looking for the value, if this array contains the value key or not. Okay, so write a function to find the match index. So please return the index. Return the index of the value equal to the key. Return the index number. If the value not found, just return -1. So we need the capacity of array, the size. I need the array is called ARR. So now how to write the for loop. Okay. Remember, you can pause the video. So then let me show you how should we write that. Okay, so that's just earlier we say. So we have index. So that's later we need to return. So we just say the index equal to -1. Okay, so we need to have a for loop. Okay, so then we start from index equal to 0. Okay, index less than size. Okay, of course, index plus plus. Okay, so actually what we do is we want to find if the array index equal to the key. So because we're looking for the value. So if we find that value, how should we do? Actually, right, I just return index. Because I find the match. Okay. Otherwise, you see here, you see, supposedly sometimes if you write the for loop, right, if you find the value, you will return the value right away. But if from the whole for loop, you didn't find that, then actually you will leave this loop, right? So when you leave this loop, the same thing, you just return. Okay, so be careful. If you find the value, you will right away return here. Val key found. Okay. However, if not, okay, be careful. You possibly never find that. So that's why after your for loop, this one actually, this line is after the for loop. So I give you one more line. Okay, so then you will return. You can either, you need to, because index already start using that for the for loop. So after you finish the for loop, the index equal to size. But if we don't find that, we return -1. Okay, yeah, so that's our linear search. So you can see here, sometimes if you are lucky, the base case, the first index equal to 0, we find the key. We only need to compare one time. But if we are not lucky, for the index equal to size -1, we find the key. We go over every time. And also worst case is if the key is not in the array, so then you need to finish this for loop. So whenever you see a for loop, that's what we call your big O efficiency is N. But this example, you see, they're only using for the int array. No matter this one will be an int array or a double array, or actually can be an object. Don't you agree we also still using the same logic to do the linear search, right? So that's why here, I don't want you just for the array is index, is integer data type. So that's why here, remember in chapter 6, we talk about the template function. So here I want to show you is the next example. We want to write this linear search function become a template function. So you can see that means here your index, your array type can be int, can be double, can be anything else. So that's why this one is the value we need to change to t. So this one you can download the example 1, the linear search. So here this example you see we will have a template function. This template function actually we have to pass in line 8. We pass a C++ array. Because remember we need to have this t. If only C array, you cannot specify your data type as t. But C++ array is a template array. So here, in order to make that as a template function, you need to have the template keyword. Type name is t. So we always pass the size. So you see, we pass the array by reference, constant reference. So here is our key. How to implement this one? Yeah, actually nothing changed like earlier our for loop. You will see the implementation. Just need to add the template keyword. So you still return the index. Okay, but here you see because your array is different data type. So then my key is also the different data type t. So you still only have one index. Okay, so your index stuff I equal to 0, I less than the size. Here is because C array you can pass the size. So then if the key equal to the index, so we return the index value. Otherwise we return -1. Yeah, so that's your template function to do the linear search. No matter what kind of data type, your big O will be N. And in this module 8, all our function, later we will write the binary search function, insertion sort function, or a selection sort function. We all need to write a template function. So we can run this example. So we have the example actually is only do the int array. So we random create the int array number. So you can ask the user for the search key. So then we will display is fine or not. So that's the linear search.